Okay, so with the larval form we have to talk about. This is the larva of mollusca. Molluscan larva. Mollusca, particularly gastropoda, particularly in case of snails we are talking about. By taking snail as an example, we are explaining this particular phenomena. So what we said, in case of larva, there is a symmetry. What symmetry is present? In case of larval form, bilateral symmetry is present. Larva is having bilateral symmetry. But during the process of growth, development, that the posterior part is growing faster and the posterior part is getting twisted itself. So that what we say simply 180 degrees angle, that the folding you have to understand, the folding you need to understand. In 180 degrees angle, the posterior part is grown with the twist. The twist and 180 degrees angle group, we say torsion. Just remember the word. Due to that, what happened? The bilaterally symmetrical larva became as asymmetrical adult. In any plane, you don't get equal half. The snail adult, that is to accommodate in the shell. This kind of development and growth is happened to accommodate in the smaller shell. So finally, whatever it may be, bilateral symmetry of molluscans is turned into asymmetry. Bilateral symmetry turned into asymmetry. Okay, then here we need to compare with the, I said now, sponges don't have symmetry. Okay, sponges, there is no pattern of design. So that's why we said asymmetrical. Okay. Then now, gastropoda of phylum Mollusca is also not having symmetry. So this is also asymmetrical. Okay. What is the difference? This is asymmetrical from the beginning, but this is actually should have bilateral symmetry. But due to the special adaptation, due to their personal adaptation, they became asymmetrical. So what do you say it as? Secondarily asymmetrical. Okay, so for your understanding, for your better understanding, what I am saying here, that in front of the temple, there is a beggar. There is a beggar. Beggar one, beggar one, and beggar two. The first beggar said, I am the beggar from by birth, inheritance. Okay. Second beggar says, then due to the corona, due to the COVID-19, I became beggar. Okay. So what is the difference? He is the rich man before. Then, so what is the difference here? He is primarily beggar from by birth. Okay. That circumstances made him beggar. So what do you say? Secondarily. Got my point here? Secondarily. So phylum mollusca of class gastropoda actually, phylum mollusca of class gastropoda actually should be that asymmetrical. Actually, they should be, bilaterally symmetrical. But now what symmetry they have? Asymmetry. So that's why it is called secondarily asymmetrical. Similar case, we'll discuss in case of Echinodermata. Echinodermata. Okay, so phylum Echinodermata belongs to the grade Bilateria, isn't it? That means echinoderms also have what type of symmetry in echinoderms? Bilateral symmetry. They should have bilateral symmetry. Then if you take the larval form of echinoderms, definitely the larval form is having that typical larval forms. These are actually that these larval form is having that bilateral symmetry is there. In case of echinodermata, the larva is having bilateral symmetry. But when this larva is growing into, this is the larva with what symmetry? Bilateral symmetry. Because it belongs to great bilateria. When larva is growing towards the adult, that to live in the marine water, they have an adaptation that 5 arms. So that's why they show radial symmetry. Which radial symmetry we said earlier? Pentaradial symmetry through which 5 planes. The 5 planes, pentaradial symmetry. Okay. So what do you say this kind of radial symmetry? This kind of radial symmetry can be called secondarily radial symmetrical. Cnidarians are having symmetry. That what do you say that as? Primarily radial symmetry. Then here, these kind of symmetry in case of echinodermata can be termed as secondarily radial symmetrical. We need to say that. Secondarily radially symmetrical organism. Okay. So that is the issue. And need to discuss about the human being easy, even, isn't it? So that what is the rules of bilateral symmetry? That the paired organs on either sides of the bilateral symmetry equidistant. The single one should be above on the axis. But we have some exceptions, like as I said about the heart. Heart is there on left side. Okay, the heart is there on left side. So what that these are all adjustments. But when you see the exact bilateral symmetry, that we are saying in mollusca, that in echinodermata, in case of human beings, so many adjustments, so many exceptions. So when you see, if you want to see the exact symmetry, if you want to see the perfect bilateral symmetry, you have to look forward towards the embryonic stages. So to give that conclusion, if you want to see the perfect bilateral symmetry, exact bilateral symmetry, okay, so you have to visit the embryo. That's all. You have to visit the embryo. Embryonic developmental stages only that having this perfect bilateral symmetry. Because when it is becoming adult, their personal issues will come here. Their personal issues, like in case of the gastropods of phylum mollusca, we are seeing they are asymmetrical. Like in case of echinodermata, they became pentaradial symmetrical. Okay, so then in case of human being also, little bit some adjustments are there. So by looking all towards these, what we said, we need to have some personal adjustment. Okay, that only is given here. Symmetry of an organism is determined based on the symmetry of the early developmental stages and not that of adult. If you want to see the exact symmetry, that you need to go with early developmental stages, not the adult stages. Okay. So this is the total story of symmetry. That is the total story of symmetry. So though we say radial and bilateral, two are present, but we are seeing biradial symmetry, pentaradial symmetry with exceptions. Okay. So this is the total story of symmetry. Okay. And then after we need to go with